welcome to today's class. I believe others will join us. Let me quickly share my screen. So we'll be discussing what we mean by Cauchy. Cauchy is a mathematician. Cauchy-Euler. Cauchy-Euler second order differential equation. Can you see my screen, please?
Yes, sir. Yes, sir. I can see it.
I will solve this. Okay. Cauchy-Euler in form of, let's look at this form. It's in form of ax squared y prime prime plus bx y prime plus cy equals to g of x. And this particular one is homogeneous. Let's look at homogeneous. When homogeneous, when g of x homogeneous when g of x is equals to 0, and non-homogeneous when g of x is not equals to 0. In this case, now, let's find the solution of this form. For us to find the solution of this form, we said let's y equals to x raised to power m. Let y equals to x raised to power m. Then we can differentiate what is y prime. Our y prime will be what? M x raised to power m minus 1. Then y prime prime will be m into m minus 1 y raised to power m minus 2. Don't forget, we can call this one equation 1. Then equation 1 becomes ax squared, rather, ax squared. That is, where you have y prime prime, substitute this one there. Where you have y prime, substitute this, substitute this. So we now have m into m minus 1 y m minus 2 plus bx into mx m minus 1 plus c into s raised to power m, everything equals to 0. Don't forget, we are looking at homogeneous now, meaning our g of x is equals to 0. So at the end of the day, what we have, we can open the brackets and see what we can bring out of this. But another thing you need to check, this case now, we still have y here. We need to change this y. Remember our y is what?
S by M.
So you need to change x, y, m. So if you are changing x, it will be x super m minus 2.
So I supposed to change it that way.
No, I'm not changing it. I'm just writing. I made a mistake here. It's not changing at all. Remember, when you differentiate this, I mistakenly put y instead of m, instead of x. Did you agree?
Yes, sir. Yes, sir.
Differentiate the y prime. What do you have?
Well, after I give you MS.
So it's the same thing.
Yes.
So we can match x and x together. So when you match them together, what do you have? We have a raised to power. Remember, the power can be, the base are equal, which is x. When you add the power together, you have x 2 plus m minus 2. So at the end of the day, you have s raised to power m. Do you agree?
Yes, sir.
Okay. So I'm clean this one. So then what do I have at the end of the day? I have this m into m minus 1 plus b s raised to power m in bracket of m plus c into s raised to power m equals to 0. So at the end of the day, I have here, I can mark this one together. Something is common to them. S raised to power m is common. S raised to power m is common. Then I have a m into m minus 1 plus bm plus c. Everything equals to 0. If I open the bracket, I have s raised to power m into am squared minus am plus bm plus c equals to 0. So here, if I divide through by s raised to power m, what do I have? At the end of the day, I will have am squared minus or plus b minus am plus c equals to 0. When you solve this one quadratically, what do you have? You have a distinct root. You have distinct real roots. Then our y in this case can be C1, you have two positive answer. C1 s raised to power m1 plus C2 s raised to power m2. Any question?
So that's how you get the y.
You don't so you don't understand. Okay, solve this one quadratically. What do you get? Positive or negative?
You get positive, sir.
Yes, you get two positive. That's That's what I'm trying to explain to you. You have two positive, and when you have the positive answer, what does it mean? It simply means that you have our homogeneous form is a distinct real. Go and read about quadratic equation. Read the property of quadratic equation, whereby they are talking about the distinct, when you use minus b plus or minus square root of b squared minus 4ac over 2a. And they ask you to use this one, the one inside. So go and read about it. So that is where we form this. Now that we have two distinct roots, what do we have? We can look at the example first before we even solve anything. Let me show you from example. Then we have distinct roots, we have repeated roots, we have different roots before we now move into the method of solving this problem. So let's look at the example, because in your exam, there are questions of this nature that will be there. We've done linear before. Go and review your linear. Example 1 says x squared y prime prime plus 7. Please listen. When you see y prime prime, they are talking about what? Cauchy and second order. Take note of that. 7xy prime plus 8y equals to 0. In this case now, what is A? What represents our A in this case? Our A is equals to 1. Our B is equals to what? Anybody?
B equals to 7.
Then our C is equals to what?
8.
Good. Now, don't forget we have A m squared plus B minus A m plus C equals to 0. All we need to do is just to substitute. You don't need to prove it all over again. So if you want to substitute, what do you have in this case? We have m squared plus B is what? 7 minus A. M plus 8 equals to 0. What do you have? M squared plus 6m plus 8 equals to 0. You can break this one down to be what? M plus 4, M plus 2 equals to 0. M equals to minus 2 or minus 4. All right?
Yes, sir.
And we have our equation already to be y equals to C1 s raised to power m plus C2 s raised to power m. In this case now, we can substitute our m. So our y is equals to C1 s raised to power minus 2 plus C2 s raised to power minus 4. That's what they asked us to calculate. So in that day, when they give you this question, don't say the man is wicked. But if it is repeated, how do they write the y for repeated? Remember, this is distinct. Then if you have this distinct there, so you can have this one to be y equals to, for repeated, real roots is y equals to C1 s raised to power m plus C2 s raised to the power m ln x. So let's look at it. Number 2, we have 9x squared y prime prime plus 3x y prime plus y equals to 0. So what is A in this case?
A is 9.
A is 9.
A is equals to
Is 9.
9. B is equals to what?
3x.
B is 3.
Sorry, 9 and 3.
B is
Okay.
3.
Then what is your C?
1. C is
1.
1.
C is equals to 1. Okay. When we solve this one, what do we have? We have 9m squared. Okay, you can write the formula out first before you solve it, so that people will not be asking you, where do you get it? M squared plus B minus AM plus C equals to 0. We have 9m squared plus B minus 9.
3 minus 9.
Right?
Yes.
M plus 1 equals to 0. So what do we have? We have 9m squared minus 6m plus 1
Minus
equals
6m
to 0.
plus 1.
So at the end of the day, what do we have here? Our m, we have 3m minus 1 and 3m minus 1 equals to 0. M is equals to 1 over 3 and it's also equals to 1 over 3. This is what we call repeated. That is the same answer for the M1 and M2. So in this case now we have repeated equals to C1 s raised to power m plus C2 s raised to power m ln x. That's the rule for the repeated. So we have y equals to C1 s raised to power 1 over 3 plus C2 s raised to power 1 over 3 ln x. So that's what they call this. Now, the question now is, if I have non-homogeneous, how do I solve it? If I have non-homogeneous, how do I solve it? That is the problem.
Yes, sir.
Go ahead.
Yes, sir. How can you know that? How can you know the equation is not homogeneous? How can you know?
Have did you start the class with us?
Yes, sir.
I don't think so. Your body is here,
Okay, yes, sir.
but your mind is far.
Yes, I've seen it.
Can you see it now?
Yes, when G of X is equal to 0. Yes.
So try to be here, please. So
Hello, sir.
when G of S is not equals to 0, how do we solve the problem? But before then, there are methods for non-homogeneous that we need to take notes. The first thing is you need to, first of all, look into, write the equation in associated form. You solve associated homogeneous equation. This will give you, let's look at it. Roman figure 1. Solve. Let's look at the steps. Under the steps, you need to solve the equation, yes, solve the association or associated homogeneous. Homogeneous equation. This gives y complementary. You remember, these are the y complementary. Roman figure 2. You can divide, put it in the standard form. Divide the equation by ax squared and put it in standard form, or after you have this one, the y complementary is this. Let me just give us this. Y complementary is the same thing as C1 y1 plus C2 y2, right? So Roman figure 3, let me use 1 and 2. Let me use normal figure. This is 2. Step 2. Okay, let's in step 1, put in standard form. Put it in standard form. In step 1, let's check this one. Put this one, put in standard. Put in standard form. Standard form means let everything be in order that you already put it. Let your your first term be ax squared, first term, let it be y prime prime, and so on. Then next thing is number 3, compute number 3 will be use variation of parameter. Use variation of parameters method to find y particular, that is yp. So while you are trying to use variation of parameters, there's a method we call Cauchy-Euler. That is, compute the Cauchy method. So how do we do the Cauchy method? We have it to be W equals to y1, y2, then y1 prime, that is you differentiate y1 prime and y2 prime. So how do we do this? How do we do this? We have W1 to be, this place will be 0, this place will be y prime, y2, f of x, y prime 2. We find its determinants. Also, we have W2 to be y1, 0, y1 prime, y2 prime. So that's the method of Roskian. Please write those methods down because you will need it. Number 4 says compute U1 to be W1 over W dx, then U2 to W2 over W dx. Don't forget, you already have W1 here. This is your W1. This is your W2. Then number 5 is your y particular. The y particular is U1, Y1 plus U2, Y2. You can see the reason why you need to do the U before you solve the problem. Any question? Okay, let's look at the example.
Sir,
Go ahead.
Sir, this method will be easy to solve the non-homogeneous
Exactly.
equation. Okay.
Yeah, exactly. Because the one of homogeneous, you will have resolved the one of non-homogeneous. Remember?
Yes, sir.
Are we ready?
Yes, sir, ready.
Okay,
Yes,
let's
sir, we
look
are
at the
ready.
example. They are very simple one, but all you need is just to know the method of solving it. Once you know the method of solving it, once you see the question in exam, or you will be able to answer it correctly. Okay, let's look at the example. Example 2 or 3. Is y prime prime plus 3y prime plus 2y equals to 1 all over 7 plus exponential x. Now you can see the difference between when it is equals to 0. So what are the things we need to do? We need to use our method. But before then, that's example 3, but this might be complex a bit. Let's look at example 4. Let's start with the small one. We'll still come back to example 3. Example 3, if time permits us, x squared y prime prime minus 2xy prime minus 4y equals to 1 all over x. So how do we resolve this one? We need to follow the method of solving it one after the other. So one of the methods is, okay, let's solve it. Solution. Now, remember, first thing you need to do is to make this equation, this particular equation, to be in homogeneous form first. Solve this homogeneously and get your y complementary. That is the first step. Can somebody read the first step for me?
The first step say solve the associated homogeneous equation.
Solve. You need to solve it, the associated one homogeneous equation. So now we have, how do we do that? The formula say am squared plus b minus am plus c equals to 0. And associated homogeneous is x squared y prime prime minus 2x y prime minus 4y equals to 0. Do you agree with me? What is A? A is equals to
A
what,
is
please?
1.
A is equals to 1, right?
Yes, sir.
B?
B
What
is
is B?
minus 2.
Minus 2.
Minus 2.
Okay. Then C.
Minus 4.
Minus 4.
Let's substitute all this. When you substitute it into the equation, what do you have? You have m squared minus 2 minus 1m minus 4 equals to 0. You have m squared minus 3. What do you have? Is it minus 3 or plus 3?
Plus 3. Plus 3m. You have plus 3m.
Sorry. This is plus. You remember?
It's minus. So it's minus. Minus.
From the formula is what?
Yes, that's correct.
Is it plus or minus?
That is minus.
It's plus.
It's minus.
Look at this now. Bernard, don't you check your book?
Yes, I formula is minus, yes, sir. But that bracket, if you give you minus. So amount has plus is minus.
Yes, this one will now touch to minus. I'm talking about the sign here.
Okay. Yes, sir.
Because if you say it's minus, it simply means minus times minus is plus.
Plus, yes, sir.
And you missed it at that point. Minus 4 equals to 0. Then you have, what do you have? M minus 4, M plus 1. Do you agree?
Yes, sir.
Our M is equals to 4, negative 1. Do you agree with me?
Yes, sir. By position.
So here you have YC, which is Y complement to B. What is C1? We have C1 S raised to power 4 plus C2 S raised to power minus 1. Then don't forget our YP will be U1 Y1 plus U2 Y2. Is that not supposed to be our Y prime, our YP rather? Any question on that?
But sir, we have not solved you.
Yes. Do you even know Y1? Answer my question.
So Y1. Yes, so you have someone Y1, and Y is our value we got.
Like seriously? So who can tell us the next thing to do, please? I'm waiting for you guys to talk.
To put it in standard form.
Yes. What happened after standard form?
Then we use a variable variation of parameters.
What is standard form?
Therefore, you should make it y prime prime.
I just asked the question, nobody answered it. What is y1, y2? Look at it critically and answer me. Who can tell us? Remember that this is the same thing as yc is the same thing as c1, y1 plus c2, y2. Do you agree?
Yes, sir, you said it. Yes.
So let's proceed. Now that we know, we need to substitute Roskian. Let's go to the Roskian method. Please just mute yourself, except when I ask you a question, or else I'll send you out. Please, Bernard.
No, so I'm not the one.
You are the one. That's why I said you should mute yourself. So just mute yourself. If you want to talk, you on it and you off it again. Thank you. Okay. Let's proceed. For M1, we know that Roskian tell us is y1, y2, then Roskian says y1, y2, then y prime 1, y prime 2. That is our Roskian, right? Then we can also, which is equivalent to, so what is y1 in this case now? Somebody should tell us. S raised to power 4
S raised to power 4
and s raised to power minus 1. Then if you differentiate y1, what do you have? 4s raised to power 3. If you differentiate this, what do you have? Minus s raised to
minus
power
x raised to power minus 2.
Thank you. So now, if you solve it as if you are solving determinant theorem, this multiply this. So what do we have? Anybody? What do we have?
S.
We're going to have s raised to power 4 multiplied by minus s raised to power 2. Minus s raised to power minus 2. Don't forget.
I want to be minus s raised to power
minus 4s raised to power 3 multiplied by s raised to power minus 1. So when you solve this one, you have what? This is minus s raised to power 2 minus 4x squared. So when you add the two together, what do you have? 4x raised to power 5x rather minus 5x squared. Do you agree? That is our
yes,
W.
sir.
That is our W. Then we need to go and solve for W1, W2 before you get your U1, U2. For W1 and W2, W1 says 0, Y2, the last one is what? What do I give you?
f of x.
F of x. So how do we compute f of s? Our f of s is the same thing as g of s over anything that is there over ax squared. Although others do their own f of s in different ways, but it's still the same. Still the same f of s. What do we have here? We have f of x to be then y prime 2. Now, so don't forget f of x. Our f of x is the same thing as g of x over ax squared. Don't forget that. So in this case, we have 0. What is y2? X minus 1. Can we calculate g of x, f of x, everybody? Calculate your f of x and tell me the answer. I just told you f of x is g of x over ax squared. All you need to know is what is our ax squared. We know our a to be 1, and we know x squared. So all you need to do is just to divide it by x squared. So what I'm saying invariably is the same thing as 1 all over x divided by x squared, which is the same thing as s raised to the power minus 3. Do you agree with me?
Yes, sir.
Thank you. So we have s raised to the power minus 3. By the time you go through the video, you will understand. Don't worry. Minus, what is y prime 2? y2 prime, rather. y2 prime is here, is the same thing as the one we put here, which is s raised to the power minus 2. Where you don't understand?
So is that f of s that we did?
It's very simple. What is f of x? The formula for f of x is here. You can use this one or use any other method of solving it. Majorly, we use this as our f of x. Now, if you use f of x to be this, what will happen to it? It is very simple. What is g of x, initial one you are given? You know it.
Yes, sir.
Substitute it there.
Then the a squared.
As squared is the same thing that we use from the original method. And we know as squared to be a is 1. S squared is still s squared, divided both sides. We use it to divide this one. And 1 over x divided by x squared will give you x raised to the power minus 3, and you put it here, and that's settled it. All you need to do is just to cross multiply the way we did in the other one. This will be 0 minus s raised to the power minus 1 into s raised to the power minus 3. So what do we have? So we are going to have s raised to the power minus s raised to the power minus 1 all over x raised to the power 4. That is going to be the answer. If you solve this one very well, you know, this multiplied by this plus this, what do you have? You have s raised to the power minus 4. Then when you bring it down, it's going to give you this. So our y1, our w1 is this. So you do the same thing to w2. For w2, you have, What is the formula for W2? We have y1, we have 0, then we have y prime 1, and we have f of x again. Don't forget your f of x where we calculated it. Then we can substitute it. What is y1? Our y1 is, please check your notes. What is y1? Anybody? Nobody. Y1 is equal to what?
y1 equals to x raised to power 4.
Thank you. And we have 0 here. Then what is y prime 1? y1? 4s raised to power 3. Then s raised to power minus 3. Our f of x. So at the end of the day, when you cross multiply, you have 0. You have cross multiply, you have x minus 0, which is equal to x. So then our u1, your u1 prime is equal to what? U1 prime is w1 over w, which is the same thing as -1 all over x4 divided by what is w? Check your note. W is equal to what?
W is equal to
5x squared.
Minus
5x
5x squared.
I think it's minus, right?
yes, it's
Minus, yes, minus 5x
Minus
squared.
cancel minus. So you have 1 all over 5 s to the power 6. Then we now remember this is, we only need u1, but we are given u prime prime to be equals to this 1 all over 5 raised to the power x6. All you need to do is just to integrate both sides. So what do we have when we integrate both sides? We have, when you integrate this side, you have u1 equals to integral of 1 all over 5 x6 dx. So here we can take 1 over 5 out and integrate s to the power minus 6 dx. When you integrate s to the power minus 6 dx, what do you have? Anybody? I am waiting.
So I'll give you
Integrate s to the power minus 5.
so then I'll give you s is for minus 5, s for minus 4 over minus 4.
I'm waiting. Anyway, when you integrate it, you have, so you can integrate s to the power minus 6. Anybody? You remember you have 1 all over 5 outside. When you integrate s to the power minus 6, everything is addition. S to the power minus 6 plus 1 over minus 6 plus 1. So at the end of the day, you have 1 over 5. Then you have what? S to the power minus 5 over minus 5. So which is the same thing as negative 1 over 25 s raised to the power minus 5. So that is for U1. This is U1. Then for U2, you have it to be integral of U2 over W, which is the same thing as what is U2? X all over minus 5 over squared, which is the same thing as 1 all over negative 1 over 5x. So if you integrate, that is the U prime. So if you now integrate both sides, so you are going to have U2 equals to integral of negative 1 all over 5x dx is the same thing as minus 1 all over 5 integral of dx over x. At the end of the day, you have, what do you have? You have minus 1 all over 5 ln x, absolute value of ln x. So I can go ahead and write, this is my U2. I can write my y now, my yp. My yp is same thing as U1 y1 plus U2 y2, which is the same thing as yp equals to U1 is what, please? Negative 1 all over 25x what is our our y1 is what, please? Anybody with y1?
X raised to the power 4.
Okay. S raised to the power 4 plus minus 1 all over 5 ln absolute value of this. Because U1 and U2, they are there. So when you match these two together, what do you have? You come up with yp equals to negative 1 all over 25s minus ln x over 5x. So the final answer in this case will be y equals to yc plus yp, which is the same thing as C1S4 plus C2 over x minus 1 all over 25x minus ln absolute value of this 5x. Any questions?
That is question. No.
Yes, what's the question?
So the margin and the final, your wife, you now do get that minus 1 over 25s.
Take your time and look into it. Which one? I did not solve anything. All I did was, listen, all I did was I just substituted we calculated this one together. You know, U1, Y1, substitute it. That's what I did. I did not do any other thing.
No, yes, I'm concerned that the last part where we have minus 1 over 25s. That's why I'm not clear.
Can't you see minus here?
Yeah, I can see it there.
Will it disappear? It's the same minus you are seeing here.
Okay, okay.
And remember, when you add this one together, you'll be x raised to power minus 1. Definitely, it will be on denominator, not on top. So, what else did I do?
Yes, I've gotten it there.
You need to work on your game so that you can also flow along the line. Any question from any quarter, please? I'll give you a question now, and I will ask you to solve it using the same method.
This method is mad, though. Hey.
Are you talking to me?
Yes, I said this method.
Yes. What happened to the method?
The method is very lengthy.
It's because I'm explaining to you. If you are doing it on your own, it won't give you problem. Plus 4y equals to, this is y prime, equals to x squared. So you can solve all these questions on your own, including the one I left behind. You can solve it. All what this question is talking about is just want to test your ability to integrate and differentiate, and that's all. If you can do the both things, I think you are good to go. But one of the past questions that I noticed, one of the questions that I've seen so far, sure, you will see this question. Don't be in denial. Don't say, yeah, it won't come. It will surely come. All I want to do for you is just to push yourself to be able to get it right. Okay, let's look at this. It's just a digression. It's one of the exam questions in 2017. They put it this way, say, find the general solution of y prime minus ay equals to 0. Let a be a constant. So for you to solve this problem, what do you have to do? Then B, this is A. Did not say B. This B might be another question in your own case. Solve the initial value. Solve the initial value problem. So how do we solve this one? Solution now. Remember that you have y prime minus ay equals to 0. I'm solving the question. This is the part of the exam question. So you have this, which I can rewrite it by saying, making a subject of formula, I say y prime equals to ay. Our a is equals to y prime over y. So I can have something like this, but this is not the equation I'm looking for. But let's look at this one. This is meaning the y, the x equals to ay. I can look for using separable variable now. If I use separable variable, I will have the y over y equals to a dx. Do you agree with me? Y over y equals to a the x. So if I integrate both sides, don't forget a is constant. I will have ln y equals to ax plus k. K is a constant too. But I'm looking for y. What will I do? Anybody? Right here. How do I get my y? Nobody, right? When we get to exam hall, we can get the y. Thank you. Anybody?
So is it log?
Is it what?
Log.
You already have the log. In this case, you use exponential.
Exponential.
They take exponential, share both sides. So you have in this case now you have exponential ln y equals to exponential as plus k. At the end of the day, exponential cancel. Remember, exponential always cancel the ln. That is exponential ln. If you punch your calculator, it will give you 1. So you have it to be absolute value of y equals to a dot exponential k. And I know that exponential a or exponential k is still constant. So I can boldly say that in this case now, our y, absolute value of y is the same thing as c exponential ax. C exponential ax. So in that day, if the question stop at this place, if they said they should find y, they can actually they give you different options. Y is equals to this, y is equals to that. But where in this case, I can further by saying where c is the same thing as my c is the same thing as is either positive or negative. Don't forget, because if I have it to be exponential k, if y if y greater than 0, then negative exponential k if y less than 0. So I'm just giving you the idea that what can happen to y if I use this. By y, this is what they ask you to calculate. But I'm giving you the condition that c will be in this form if y greater than 0. Now, part B of the question, part B of that same question says, imposing the condition, we are given the condition, right? For us to impose the condition y of x of naught equals to y naught will be y naught equals to c exponential ax naught. So we need to calculate our c. What is going to be your c in this case? So our c will be y naught exponential minus as naught. So if we have this, we can now substitute our c back to the equation. If I substitute c into this, I know c is equals to this based on my analysis. Then what will happen to my y? What will happen to my y if my c is equals to what I circled. So I'm going to have y to be equals to y naught exponential. I'm writing c now, this particular one, minus a x naught dot exponential ax. If I match the two together, I will have y naught exponential a in brackets s minus s naught. So that is what will happen based on the boundary condition you are given. Remember, you are given from day one the boundary condition. Let's look at it. It says solve the initial value problem. Solve initial value problem when you have, I didn't even finish this, y1 minus ay equals to 0 and y of s naught equals to y naught. That's the value problem they asked us to solve. So you will see a lot of questions of this nature in your exams. So let's look at this. There are simple question is what you know. Part of your MCQ too. So find the general solution of y prime plus 2y equals to x raised to the power 3 exponential minus 2x. Remember, we've calculated it the other time. We know that our y is equals to c exponential ax. What is a in this case? Who can tell us? From the above question, a is equals to what? Hello? What is a? A is what? From the above question, a is what?
Yes, it should be 1.
A is 1. No, not that kind of a. Look at the a from this.
Okay, minus 2.
A is minus 2. Thank you. So, which means I have my y1 will be exponential minus 2x. So I can go ahead with what I have. But don't forget you have y prime plus 2y equals to 0. Let y equals to u exponential minus 2x. Let y equals to u exponential minus 2x. But in this case, how do we solve this one? Remember when we are doing comparison, the last time we did that, so what is y prime now? According from this one, what is y prime? Who can tell? How do we differentiate it to get y prime? For us to get y prime, everything u also is a function of x. So we'll hold one constant and differentiate one. So let's differentiate u first. So u would be u prime exponential minus 2x. Then let's differentiate exponential 2x. I will have minus 2 u exponential minus 2x. So that's what I will have. So I can substitute it into this equation. Call this one equation 1. Equation 1 becomes what? U prime exponential minus 2x minus 2u exponential minus 2x plus 2, these two, what is exponential y? What is y? Y is u exponential minus 2x. So I can match the two together. At the end of the day, what do I have? If I add the two together, what do I have? Is anything in common? Yes, we have this one in common. So we will have what? At the end of the day, by the time this cancel this go with this, so you have this left. So it simply means our y prime plus 2y equals to u prime exponential minus 2x. U prime exponential minus 2x. But don't forget the equivalent. We know that u prime exponential minus 2x is the same thing, is equivalent to s raised to power 3 exponential minus 2x. Remember from the question you are given s raised to power 3 from here. Remember from here, you are given this. And we've calculated this one equals to u prime exponential minus 3 exponential minus 2x. So we can go ahead and substitute the two together. What do we have? At the end of the day, this goes with this. With that said, u prime equals to exponential 3. So what's going to be our u? Our u means u will now be integral of x raised to power 3 dx, which implies that s raised to power 4 over 4 plus c. And our y is equals to u raised to power n minus 2x. So we know that this is equals to this. Then we can proceed and substitute the value. We know the u now. Our u is equals to what? This is our u. So we now have y to be equals to exponential minus 2x into 1 into x is to power 4 over 4 plus c. That is our general solution. Any question, please? Any question? Silence means no question. Any question, please? Emmanuel, any question? Abu Kadri, Memuna, Favor,
No questions, sir.
Okay. So I want you guys to try as much as possible to find your time. When are you writing this course? Is your timetable out now?
Yes, sir,
It's the
out.
draft.
Out.
Is it draft
No.
or final?
No, the final is out. The final is out.
When are you writing the course?
We're writing it on the 14th of June.
14th of June. Okay.
Yes, sir.
Okay. I wish you guys good luck. You still, even let's say you've not even started the class before, this is your first day, you can as well go to my YouTube channel, download all the previous videos. Is there on your portal too? In case you have problem with your portal, go to the YouTube channel, download it, topic by topic, then you can easily solve it. Any question? Favor?
Yes, sir. No question, sir.
No, sir. No question, sir.
Okay. Priye?
No question, sir.
Bernard?
Yes,
Gosby?
sir. No question, sir.
No question, sir.
Memuna? Okay. If you don't have questions, I've been waiting to hear from you guys. So see you guys after
Thank you
your
so much,
exam.
sir. Yeah, thank you,
After
sir.
your exam now. Today is the last day. Let's